say when we were in the previous class, no, we were learning about the magnetic material. Okay, so first we saw the prerequisites of the magnetic material, which what was necessary for us to know. In there I told you that about this thing already you read in physics, right? So where you learn about the magnetic dipole moment, then there permeability, susceptibility, and magnetic induction, magnetization, magnetic field intensity, and the relationship between your susceptibility and your uh, uh, relative permeability. Okay, so these things you have learned in physics, and for your convenient only I took the screenshot from your physics note which is shared by your sir in group. From there only I took the screenshots and I put it here for you people's easy understanding, which you already know. Okay, after that, basing on the two categories or two criteria, we have divided the magnetic material as paramagnetic, diamagnetic, and ferromagnetic, that is depending on relative permeability. Similarly, based on the magnetic dipole moment, we have categorized as your diamagnetic material as well as paramagnetic, ferromagnetic, antiferromagnetic, and perimagnetic. And we saw the difference between these diamagnetic, ferromagnetic material, as well as we learn what is this antiferromagnetic and perimagnetic material. Okay, so here, depending on the direction and the magnitude of your magnetic dipole moment of the material, we classified it as your paramagnetic material, ferromagnetic material, antiferromagnetic material, and ferrimagnetic material. In paramagnetic material, the dipole moment is not having a uh, not even you place the material in a magnetic field, it will create the magnetic dipole moment, but its direction will be random. But in case of a ferromagnetic material, it will be lying in the direction of the magnetic field, in the external magnetic field which is induced. Okay, or in which magnetic field we kept, no, the direction of that magnetic field, external magnetic field, and the magnetic dipole moment of the material, both will be having the same direction and they will be parallel. In case of an antiferromagnetic material, there will be both direction, same direction magnetic dipole moment, and opposite direction magnetic dipole moment will be there. They will be alternately arranged with same magnitude. But in case of ferrimagnetic material, the same direction dipole moment will be more than the opposite direction magnetic dipole moment created in the material. So this is what is the four difference of the four different type of magnetic material which we have classified according to the magnetic dipole moment. But basically these three are most important. We learn about this one very frequently. So what we did is that we have learned the difference between ferromagnetic material, paramagnetic material, and diamagnetic material. Okay, I have told you in detail all the differences between these three different type of material, that is in the video, and as well as the physics note which you received in that one also, it is also there, and I will share the note very uh, quickly. Okay, by today or tomorrow I will share. Sorry for the late sharing the notes, because due to some problem I am not able to share uh, quickly. Then what we learn is that BH curve for the ferromagnetic material. Okay, this is a BH curve. Okay, this BH curve, remember this one, this is a characteristic curve, you can say. This is a characteristic curve for different magnetic materials what we are using. So I have told that day about this BH curve, but still I received the request from some students to repeat this one. So I am starting from this point again. Okay. So as you can see here, this is the graph plot between your this one this is your H. Okay, the external magnetic field what we are uh, introducing, and the magnetic flux induced in the material. Okay, so this is your magnetic field intensity in which you place a material, and this is the flux induced in the material if you place the material in a particular amount of magnetic intensity or external magnetic field. So what happens when a material is not placed in a, this is actually, this curve is for ferromagnetic material. Okay, so before placing or before keeping it any kind of your magnetic field, initially there is no magnetization we can see in case of your material. But when we place the material in a magnetic field, then we see that there is some amount of, if we will place a material with this amount of magnetic field, then we find that there is this amount of magnetic field in field or magnetic flux is created in the body. Okay, so what happens now, this particular curve is going to show us the, if we will increase the magnetic field intensity, then what is the effect we can see on the magnetic flux of the, or the magnetic flux created in the body. So what exactly happens in case of a material? So in case of ferromagnetic material, as we know, in case of ferromagnetic material, there are moments, dipole moments are there, but these dipole moments are initially arranged in a very what you can say, random manner. Okay, so there will be sections where the dipole moment is acting in direction, in this direction. There are sections where the dipole moment will be acting in this direction. These are the sections I am saying. Okay, exactly in the material, this is not the pattern they will be following. So what we are doing, what I did here is that I just took the same direction magnetic dipole moment and I gave them some area. Okay, so what happened now, this is the arrangement, or this is the dipole moments of the material created. Now what of the material when it is not placed in a dipole the magnetic field intensity, or there is no magnetic field is there, it is a normal ferromagnetic material due to the earth's magnetic field. This is the arrangement of the magnetic dipole moment we see in case of your material. Now what I did is that I place this material in a magnetic field intensity area or magnetic field. Then external magnetic field is there, I place this material over there. So once I place this one, no, these magnetic fields are going to pass through this material. So due to the effect of this external magnetic field, the dipole moment here are going to change their direction and lie along and parallel to this external magnetic field. So what will happen? So it will be looking like after some time, after some time of your keeping the material in the magnetic field, we will observe that some of the electrons have, or some of the electron have achieved the magnetic dipole moment like this. So basically we can say the number of electrons are going to be increased over here. Okay, so here this direction magnetic dipole moment will be there, this direction magnetic dipole moment will be there, and this direction magnetic dipole moment will be there, even if it is placed in a magnetic external magnetic field. But there will be more number of electrons which will be having the magnetic dipole moment parallel and along the direction of the external magnetic field. So this conversion process will be carrying on for some time. Once all the electrons achieve this particular direction magnetic dipole moment, at that time we say this particular material reach its saturation point. Okay, reach its saturation point, we say it reaches saturation point. Okay, so when I am saying a saturation means it is the maximum limit. More than that we cannot go, like in case of our any kind of solution you are making, like your the sugar solution or salt solution you consider. So the water is going to dissolve the sugar up to a maximum point if it is in a normal temperature. Okay, if it is in normal room temperature, there is certain point of sugar or certain amount of salt that will be going to be dissolved in the water. If after that you add sugar or salt, it will not dissolve, rather it will present in a different phase. You can identify that one, this is sugar and this is water. Okay, this is also happening in this case. Okay, when you are keeping the material in a magnetic field, the dipole moment means what, all the electron are going to attain the same amount of magnetic dipole moment as that is the external field is possessing, and it will lie along the direction of a magnetic induction or the magnetic field, external magnetic field we can say, and the electrons are achieving that one in a particular process. So as I told you, if we will consider in this graph, we will consider this is point A, and at this point A, this is the magnetic flux created in the body. Means we can say that this is the situation of second situation. Okay, in this case some electrons are yet is there, they are supposed to attain the direction of the external magnetic field and amount as well, magnitude as well. But if I will consider this particular point here at, let us consider this is your A1, then this will be your A1 state, where all the electrons attain the same direction magnetic dipole moment, and there is no more electron left which will be lie along the direction of applied magnetic field or external magnetic field. So that is called as a saturation point. After that, even if you increase the value of H or magnetic field, it is not going to change, it will be a straight line only. Okay, there will be no change in the magnetic flux you will identify over there. So what happens here, from 0, if you increase the magnetic intensity, the magnetic flux created in the body is going to increase little slowly. Okay, initially it will increase slowly, then it will increase rapidly, then again it will increase slowly, and then it will reach the saturation point. So this is what is the curve it is going to follow. So as I told you, so if I plot a graph between if I plot a graph between B and H, this is your external magnetic field and this is the magnetic flux created in the body. So initially what happened, I will start from 0. So here when I am increasing gradually the magnetic field, no, then the amount of magnetization will be slowly increasing. Then it will increase rapidly. The slope will be having a higher value. It will increase rapidly. Then again it will increase slowly. Initially it will increase slowly, then it will increase rapidly, again it will increase slowly. Okay, then it will reach to the saturation point. Okay, so this is the phase 1, this is the phase 2, this is the phase 3, then this is called as your saturation. But it is not going to follow the same path when you will decrease the value of H further. Once it reaches the saturation point, when you decrease the magnetic field, the magnetic flux, reduction in magnetic flux will not follow the same curve. How it will go? It will go in this second curve, what you can see over here. This is the reduction center I am representing as the second curve. Then it will follow the second curve. That means what? Once your material reaches to the saturation point means what? You increase your magnetic field intensity to such a value that the magnetic flux created in the body is reaching to the highest point or saturation point. After that, when you are decreasing the value of your magnetic external magnetic field, the magnetization is not going to follow the same path S0 to A or O to A. It is going to follow A to B, B to C and C to D curve. Okay, so in that process you can see if I am decreasing the magnetic field, I reach to a point B where the magnetic field intensity or the external magnetic field is 0, but still the material is having some amount of magnetic flux. Okay, that is called as your residual flux, or we also call it as your retentivity. Or we also call it as the retentivity. Okay, so now to remove this residual flux, how much amount of your magnetic field intensity is required in a negative direction, that is called as your coercive force. Okay, in a negative direction you need the magnetic field intensity, that is called coercive force, which will make sure that the residual flux is going to be 0 or the residual flux is removed from the material. If you further decrease the value of magnetic field in a negative direction, there also we find a saturation point. After that, there will be no more magnetic flux. You will increase in the magnetic flux or decrease in the magnetic flux you will observe. Okay, there will be no more decrease in the magnetic flux. It will reach to this saturation point. After this, how much more you decrease the value of H, it is not going to change. It is going to follow this same straight line. Okay, this is saturation. Next, let us consider if the material reaches to the saturation point D. After that, we further increase the value of H. So if we further increase the value of H, we see that it is going to gradually, the magnetic flux in the material or magnetization of the material is increasing, and there is this reaches this point E, where we see that even though the value of magnetic field intensity is 0, magnetic field intensity is 0, magnetization is not 0. It is having some negative retentive value or residual flux. To remove this negative residual flux, if we increase further the magnetic field, we reach to this F point, which is where we find that the magnetic flux is 0, but not the magnetization is 0, but not the magnetic field intensity. Okay, H will be 0, but not B is 0, not H. At F point, B is equal to 0, but H is having some amount of value. Okay, so this, after once the saturation point is achieved in the material, no, this is going to follow this A, B, C, D, E, F curve. This curve, it is going to repeat. This is called as a hysteresis loop. Okay, it is a loop. Loop means what? Like this circle. If you start from A point, you're starting from A and reaching to A. Again, you are moving in this curve, in this circle, but you don't know which is the starting point and which is the ending point. That is called as a loop. Okay, you are reading in reading C programming class now. In that one, you must know what is a loop, right? So because you are doing the programming, then you must know what is a loop. So this is what is exactly the BH curve for a ferromagnetic material. It looks like. It is also called as a hysteresis loop. Depending on this BH curve of a ferromagnetic material, we are having two different type of material. One is called as a soft material and another one is called as a hard material. Okay. soft material and hard material. So I think I have seen in your physics note further that regarding the soft material and hard material, magnetic material is given in there. Okay, so I think you have some idea about this one because you already read this one in physics. So I am just going to give you a comparative value or comparative study of this um, soft material and hard material. Okay, give me a minute. Okay, so if you have any doubt from hysteresis loop, you can ask now. Put it in the chat box. Meanwhile, I am continuing with the soft material. If you have any doubt regarding this hysteresis loop, you put the message in the chat box. Okay, so now comes the soft material and hard material. This is soft material and hard material we are reading regarding your magnetic material. Okay, so soft material are those material which material are very easy to magnetize and demagnetize. Okay, so here what happens, we can say if we keep a soft magnetic material in a small magnetic field, then what will happen, it will easily going to get magnetized. Okay, very small amount of magnetic field intensity will also enough to magnetize the material or soft magnetic material. Similarly, if you remove that magnetic field, then it is going to be getting demagnetized very quickly. That is what is a soft magnetic material. But in case of a hard magnetic material, it is very difficult to first magnetize. Then once it is magnetized, it is again difficult to demagnetize. We will see this point with relation with relative to this hysteresis loop. What does it mean? Okay, so we can say this particular materials are easily magnetized and demagnetized. And demagnetized. But these materials are difficult to magnetize if once it is magnetized. it is again difficult to demagnetize that one. Okay, it is difficult to magnetize as well as very difficult to demagnetize again. What does this mean? This point means that if we are applying a small magnetic field also, if we will apply here a small magnetic field also, magnetic field means here I am saying the value of H. Okay, if we are giving small amount of value of H also will give us a higher amount of magnetization, that is the B value. So we can find large magnetization. But in case of your hard magnetic field, no magnetic material, no in case of hard magnetic material, the large value of magnetic field will result small value of your magnetization. Small value of magnetization. So here what happens in soft material, small magnetic field we are getting large magnetization, and as soon as you remove the magnetic field we can demagnetize the material. But in case of your hard magnetic material, first of all it will require a very large amount of magnetic field to magnetize the material. Once it is magnetized, again it will require very longer time period or very difficult, very high energy coercive force to demagnetize the material again. Okay, so because of this, no, here we will get a hysteresis loop like this. Okay, so as I told you, it is very easy to magnetize. So with a small value of your magnetic field, the magnetization we will get will be more. Okay, so here what happened, as I told you, if I am increasing the if I will increase the magnetic field like this, then I will get a very small loop of hysteresis. Okay, the hysteresis loop is a smaller one, relatively smaller one as compared to your hard magnetic material. But in case of hard magnetic material, it is very high, it requires more energy to magnetize. So the more the energy to magnetize, the bigger the hysteresis loop will be. So I think you can differentiate between these two hysteresis loop. Here a small amount of magnetic field is required to get the saturation point, then that small amount of demagnetization force is required and the loop is going to be repeating itself. Okay, so but in case of your hard magnetic material, first of all we need higher amount of value of H to get the saturation point, then to demagnetize we require same higher value of your coercive force will be required to demagnetize the material. This is what is the hysteresis loop will be looking like for two different materials of soft material and hard material. Okay, so we can say here the coercive force will be less. Here the coercive force is less, but in this case the coercive force is very high. Is high. Right? What is the example of a soft magnetic material like your steel? Steel is the different alloys of iron or steel alloy steels. Okay, but your hard magnetic materials are like alloys of copper, nickel, iron, copper, nickel, cobalt. These are the example of your two different this soft magnetic material and hard magnetic material. If you have any doubt, you can put it in the chat box so that I will reply to that one. Meanwhile, we will continue with the application of your magnetic materials. Okay, in your syllabus it is written application of magneto material applications. Okay, so magneto material applications means magnetic material applications only. Okay, in when you will go to your higher semesters, you will also see that there are effects of this magnetic field are there on different materials, and there is different effects will be created. Okay, so magneto photonics and magneto optics and magnetoromic, like that different effects are there. Okay, so those effects you have to learn to understand the application. That is very deep thing, which is, I think you might be reading in your high semester. I am not sure whether it will be included in your syllabus or not, but here the magnet application of magnetomaterial means magnetic materials only. Okay, the first application we can say is your storage device. What do you mean by storage device? The earlier days we were using the storage device. I think in some movies, older movies, you must have seen something like this reels. And if you know about your tape recorder. Okay, so uh, means in early 90s, or not early 90s, before this computer era started, these storage devices were like tapes. Okay, so if nowadays you are listening music in mp3 music, you are listening, no, you are downloading from the Google Chrome and you are storing in mobile and listening. But in earlier days it is not like that. Okay, we were having something like this cassette. Okay, so in that cassette, no, there is this reel was there. There will be a thin strip will be there. When you will put this one in the recorder, no, tape recorder, it will, you will play button. You will put the push the play button. It will start to rotate. Okay, these two holes are there, no, they will start to rotate. When they will start to rotate, no, that strip is going to move on that tape, and it is going to give us the sounds, the musics. Okay, that is your tape. These are the movie reels we know. And if you have seen any horror movie, or means not Indian horror movie, I am saying the horror movie, Hollywood horror movie, then you must have seen something like this we are using in there, or that different era or different time zone movies are there, then you must have seen this type of things over there. If you remember, because this one the thing that you must have saw when you were in school, in your school days, if you were going to your what you can say, English medium schools, no, I think this type of things they were sharing, they were showing to the students. This is called as a floppy disk. Okay, floppy disk. I think this floppy disk was in use up to 20 2008 or 9, like that. After that it is overcome by CD drives. After that the CD drives are overcome by pen drives. Okay, and then memory chips came, like that. Okay, so this is your floppy disk. This is also a storage device, like we are storing data in pen drive or memory card now, like that it is also storing the data. So there will be this here you see this black strip, no, this black strip you can see, no, here there will be a CD, a circular black strip will be there in the inside that one, and that is what is going to read the data. Storage device, data storing. Okay, all the data, whatever the data we need, like your official confidential data, or if a personal data like photographs, any kind of music, or some kind of videos from the functions, like that you can store in this one. Okay. Also we are using this magnets in case of a speaker. This is what a radio. If you people are not aware, I will tell you, this is a radio. Okay, radio, this radio here, what you see here, no, in this portion, like you can see this area. Okay, color is working on this. This one, I am saying this one. Okay, in that area, no, what you can see is a speaker. Okay, that speaker, in this portion of the speaker, what you can see is a magnet. I think if you people are little bit curious about anything, no, you must have opened any speaker type device, that broken speaker type device, you must have get to see this type of things. This is a this is, or also we can say the loudspeakers. Okay, the loudspeakers that is used in your masjid for azan, right? So there also we are using this type of speakers, so that the voice will become, or the sound of the of any kind of thing, whatever we can say, either song or news readings, any kind of sound, is this going to be modulated. Okay, the volume is going to be increasing, or you will say that amplified. Okay, also we are using that one in your compass. This is called as your pocket compass. Okay, if you have seen Pirates of Caribbean, right? So this, they are using this ship, or in case of your aeroplanes, their direction is important to know, in which direction you are moving. There we are using the compass, right? There will be this magnet will be there. Always remember, earth is having its magnetic field, right? So when you are taking a magnet and you are keeping it free, then always it is going to point towards the north direction. Okay, so by using that quality of the material, we are using this one. Okay, we are using this pocket compass. Also we are using this one in case of crane. Okay, to lift the heavy weight, what happens, no, always it is not possible to hold it with the handles of the crane. Okay, or always it is not possible to hook it up to the crane hook. So what we are doing, no, we have attached this magnetic material over there, which will be going to be suck the heavy material towards it, and then we can lift it and we can move it, okay, to a different uh, location. That is what, that is, this is the magnetic hoisting of crane. Also you must have seen in very different type of industries, no, we are separating the different materials. Like in case of your food industries, you see what happened. Let us consider, we are seeing a food industry which is making chocolate. Okay, so this chocolate they are making, they are packaging the chocolate that is having some specific weight, some specific shape, right? If any deformation is there, any kind of unwanted thing is there, like in some cases it is broken, in some cases the weight is not proper, then what will happen, no, there is this conveyor belt will be there, which will make sure that the defective pieces will not go in the lot. It is going to remove that one. Then we are using this magnetic vibration. Okay, the magnetic vibration is going to decide whether the material falls in the required category or not. If not, we will remove that one. If yes, then it will go forward. Okay, we can say that it is in case of your in case of your food industry or any kind of industry, food industry, or your mine industry. Okay, in your mines, in mines also, if it is a ore material, then we can remove it. If it is a crushed stone, it will remove it by using this magnetic field. I think this is one thing you people are very well aware of. Okay, in hospital, if we anyone tell you to go for MRI, then we are going to use this particular machine, right? In this machine there is this hole is there, and we are letting this person go in the hole, and then we are doing the scan. Okay, we can scan the tissue, we can scan the bones, okay, over there. So how does exactly it works? It works on this two big magnets. Okay, this circle what you can see over here, no, this circle, this particular big circle what you can see, this is nothing but the magnet. Okay, this is the magnet, and by using the magnetic effect or magnetic magnetization, we are going to scan the density, different density material in the living organisms. Living organisms, this MRI is not only done for this human being, it is also done for animals, so that we can scan their bones and tissue as well. Okay, this is what is a MRI scanner. Also we are using this one in case of small generators. Okay, we are using in small generators. There is this permanent magnet will be there, and inside within the big magnetic material, the armature is going to rotate. This armature, when it is rotating, it will going to generate the electricity which we store in the battery. Okay, this is a generator, not inverter. Okay, this is a generator. Small generators what we are using, there we are using this one. And the lastly we can see this one. This is, as I told you, storage device. That is your data storage device. This is a thing which people are very well aware of, like your ATM cards or credit card, or also in case of some shopping malls, they will giving you the shopping cards, right? In all these things, what we are having, or if you visit any kind of your hi-fi hotel where you are staying, they will give you the card to the access to the room. Okay, there also the cards are like this only. In that one, this black strip you can see over here. Okay, that black strip is nothing but a magnetic material or magnetic tape. In this magnetic tape is having the data of the user, who is the user and what is its passcode to access the card. Okay, that data will be stored in that strip. So when we are using that one in our ATM machines or debit card machines, then what happens? No, this is going to read the data of the user and how much the expenditure the person has done, that is going to be stored in there. That is what is your application of this. Is a very common application, that's why I have shown you this one. Okay, so these are the application of a magnetomaterial, which ends the unit 4 over here. Okay, the part which I left, I told you that I will provide you a video. I got to know that we will be getting the extra period, so I put it in this one. Saturday I will have a doubt clear class. You people can go through all the videos what I have in this what I taught you in unit 3 and 4. Then we can go for this doubt clear classes. Okay, so you can ask your doubts beforehand only. Please prepare your doubt questions and post it in the group, so that it will be, the time will be not going to be wasted. Okay, so I think that today you people have not asked any doubt. Even if you are having any doubt regarding today's class, you can. Okay, second lesson, no? Okay, for second lesson I will take extra class for section B and C separately, because section A and section A and B. I was taking section B and C, no? Section B and C's second unit is not complete. I will take separate class for that tomorrow. Okay, tomorrow your class 4 to 5, I will take extra class for that leftover part of the second unit. Okay, Saturday we will be having Oh, sorry, that is what I told now, because my end I have some problem in my end. That's why I was not able to post the notes. I will try to post the note within today and tomorrow.